Alright, in this we're going to recap a little bit of this lesson of 5-5 triangle mid-segment theorem. It's found on page 491 of your textbook. Your objectives: you'll be able to use proportional parts within triangles and use proportional parts with parallel lines. Some things to know: to apply this in real life here, photographers have many techniques at their disposal that can be used to add interest in a photograph. One such technique is the use of a vanishing point perspective, in which an image with parallel lines, such as train tracks, is photographed so that the lines appear to converge at a point in the horizon. That's something you've seen before when it kind of converges there as you go down the hallway, as you've seen in our school next to the cafeteria. Now, when a triangle contains a line that is parallel to one of its sides, the two triangles formed can be proved similar using the angle-angle similarity postulate. A little bit later I'll explain more about the angle-angle similarity postulate. Since the triangles are similar, their sides are proportional. So we're going to focus on this type of style of problem. Or the triangle proportionality theorem. If a line is parallel to one side of the triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So in other words, if a line is parallel to one side of a triangle, so let's say BE, if that BE line is parallel to this particular side, CD, and it intersects the other two sides, meaning that E and B, they cross all the way to the other side of the line, then it divides the segment into segments of proportional lengths. Okay? So meaning this side length multiplied by some random number will get us this side length. That's what this is saying. Now, when they are parallel, if BE and CD are parallel, then whatever is here, that AB length divided by this BC length, is equal to this AE length, A, divided by the ED length. So in other words, X over Y is equal to the length of A divided by B in the picture. So if you had to solve for X, all you have to do, it would be AY divided by B. If you had to solve for A, it will be BX divided by Y equals A. So that's what this then statement says. Length line segment AB divided by line segment BC is equal to AE divided by ED. Now let's practice that concept a little bit. So if I have this triangle here, AB is 7.5, so we say 7.5 divided by BC is equal to AE divided by ED. And when we have that, we then cross multiply. So it'll be 3 times question mark equals, well, 7.5 times 2.5 gets us 18.75. And then we do 18.75 divided by 3. And our question mark is going to equal 6.25. So that's how you find that question mark. Let's do another one. So you got a problem like this. Problem number 2. It's the same setup. AB divided by question mark is equal to 12.5 divided by 5. So let's write that out. 15 divided by question mark is equal to 12.5 divided by 5. We cross multiply. 5 times 15 gets you 75. And question mark times 12.5, well, that's going to be 12.5 times question mark. Then we have to do our inverse operations. We divide by 12.5 to both sides. Our question mark 75 divided by 12.5 gets us 6. That's how you do that. So this length right here is 6. Now the reverse of this theorem is also true. This is called the converse of a triangle proportionality theorem. So in other words, if the ratio from A to B, this length right here, divided by BC is equal to AE divided by ED, if they're proportional, that means BE and CD, these two lines are parallel. That's what the converse theorem is saying. So now let's do something like this. In triangle ACD, DE from here to here is 3. EA is 9. CB is 1/3 the length of BA. Well, BA, we don't know what it is, but we know 1/3 of that is 1/3 times x, or literally x divided by 3. And we're calling BA x in this case. So the length of BA is x. We don't know what that is, but we know CB is 1/3. So 1/3 of x is the same thing as x over 3. So now that we wrote everything in the picture, we can determine what the value of x is that'll make these two lines parallel. Now, if it's the same proportion, we should be good to go. Now, 9 divided by 3 is equal to x over x divided by 3. Now, let's see if we could do that. 9 divided by 3 is 3. So that means this piece has to be 3 times longer than that. Well, that makes sense. This piece is 3 times longer than that because this piece is always going to be divided by 3. So this is always going to be 3, BA is always going to be 3 times bigger. So it means yes. These two, CD and BE, they are parallel. Because BA will always be 3 times bigger than 1/3 of BA. That's a little bit tricky. It's a little bit tough, but you can do it. Now, a mid-segment of a triangle is a segment with endpoints that are the midpoints of 2 sides of the triangle. Every triangle has 3 mid-segments. This means AR and RC have the same length because R is in the middle of AC. P is in the middle of AB, so AP has the same length as PB. Q is in the middle of BC, so that means QB and CQ, they're of same lengths. So just keep that in mind. It splits them in half, okay? Alright. So triangle mid-segment theorem. So when they have a BD line that looks like they're kind of parallel, and they mark them saying that AD and DE are the same length, and AB and BC are the same length, this is the triangle mid-segment theorem. A mid-segment of a triangle is parallel to one side of the triangle. Like we discussed before, BD is parallel to DCE. And its length is 1/2 the length of that side. So, when this is chopped in half, so D's in the middle and B's in the middle on this side, that means this length, BD, is half the length of CE. So if CE was 10, half the length would be 5. So BD would be 5. If CE was 10x, BD would be 5x, because half of 10x is 5x. That's what this is saying here. So if this is 10 inches, x would be 5 inches. If this is 50 inches, x would be 25 inches. Now, if we have 105, well, we know this 5x is half of this. So if we double our half piece, that would make us a whole. So if we take this guy, whatever that's on top, and we double it by 2, aka 2 times 5x, then this guy will be equal to that. So 2 times 5x is 10x, and 10x is equal to 100, because double of this half piece will get us our whole piece. So 10x divided by 10, we're going to get x equals 10. Don't worry, we're going to do a couple more of these. Let's say this problem's a little bit tougher. We have to double this piece based on the information that's being provided to us, that this is D's in the middle and B's in the middle of AC. And this line goes all the way across. That means this guy is half of this. Since it's half, if we double 2 halves, we make a whole. So if we double 5x plus 15, we could set it equal to the 120. 5x times 2 gets you 10x. 15 times 2 gets you 30. And it's equal to the 120. We do our inverse operations. We subtract 30 from both sides. We get, I'll write it up here, 10x is equal to 90. Sorry about the handwriting here. Try to go as neat as I can. Then we got x equals 9, because 90 divided by 10 gets you 9. So that's how we would solve for x. Then it could get more and more complicated as we go on. All we have to do though is keep to our basics. This guy doubled will equal this one. So 6x plus 65, well 6x times 2 is 12x. 65 times 2 is 130, so 12x plus 130 is equal to this big guy of 8x plus 135. We then do our inverse operations. We get 12x. We subtract 130 from both sides. So we get 12x equals 8x plus 5. Subtract 8x. We get 4x equals 5. Divide by 4 to both sides. We get x equals 1.25. So even when the algebra gets a little bit tough, you can still use your geometry concepts and solve for the algebra. So x equals 1.25. Our last little piece of information here is that in figure XY and XZ are mid-segments. So meaning x is in the middle of RS and Z is in the middle of ST. So they get their little double ticks. So that's what mid-segments are. It's in the middle of triangle RST. Find each measure. Well, XZ. Well, to find this measure, XZ, we know that's half of RT based on our mid-segment theorem that we just talked about. So if RT is 11, half of that will be 5.5 because 11 divided by 2 is 5.5. So XZ is 5.5. ST, here to here. Well, to figure out that one, we know XY is also the mid-segment theorem because Y is also a mid-segment. of RT. So 1, 2, 3. 1, 2, 3. 8 doubled. ST is 16. Angle RYX. RYX. To find this angle, we have to rely on some old information. This is where it gets a little bit tougher. You have to remember parallel lines cut by a transversal. Right here, XZ is parallel to RT. The transversal line is right there. So it turns out, by alternate interior angles, you know this angle right here is 99 degrees. So that's 99. XSZ, XSZ, to find out this angle up here, we're going to do a little bit of work here to get that done. Well, we do know that this line here, I know it's starting to get a little wild, this line right here and this line right here, they are parallel lines. And it's also being cut by a couple transversals. Now, what transversals can we do? Well, if we did this transversal from here to here, we know that this guy here and this angle are the same. So let's see if we can find out this angle then by not vertical angles, corresponding angles. We know that angle S will be the same as this one. So let's do that. This triangle here on the inside is 180. So 180 minus 99 gets you 81. 81 minus 67 will get you 14. So this last little angle here in this triangle is 14. You also have to remember how many degrees are on one side of a triangle. Well, that's 180. So 180 minus 99 minus 14, well, that will get you a 67 right here for that piece of the triangle. Then you know in this triangle, you know a triangle has a total of 180 degrees. You know by alternate interior angles that this angle up here is also 14 degrees, because if we use this as the transversal as before, that means this guy and this guy are 14. And then by corresponding angles, you know that this angle up here is also 14. So this one's 14. XYT, XYT. Well, if this guy's 14 and this guy's 67, you can just add them up. 14 plus 67, that gets you 70, 81. So that's 81 degrees. That's a tough one. It's a very challenging problem. Hang in there. And we're going to be doing problems like that more and more in class. All right. This is all we have time for today. If you have any questions, please come to Extra Help or ask me during class. I'll be happy to help you. Or you could even email me too. All right. Have a good night.